Hey everybody, it's Beej with Lambda School. We're going to be talking about least recently used caches, or LRU caches, in this video. So the objective here is to implement a least recently used cache. We're going to talk a little bit about what caches are, what in particular LRU caches are, and what they're made of. And we'll talk about putting things in the cache, getting things from the cache, and deleting things from the cache. So first, a little bit of cache background. What are caches? Caches are bits of storage that are fast to access, that keep small amounts of frequently used data in them. It's kind of a mouthful, but the idea is that we have some primary storage that's slow, such as a hard drive, and if we have something that we commonly access from that hard drive, it would be nice if we put that into memory and held it there, so that users could frequently get that data just from memory instead of from the hard drive, which was rather slow in comparison. So the idea is that the cache is a small amount of memory that can speed up access to frequently used information. So for example, with a hard drive, maybe we have a file on there that gets frequently accessed. We'll take that file, we'll store it in our cache in memory, and the next user that asks for it gets it straight out of memory instead of needing to go to the disk. Caches are used in a variety of places, not just with disks and memory, but also with RAM and the CPU. You may have heard that your CPU has a cache. Commonly, though, the common thing between these different types of caches is that the primary storage tends to be very big. So a lot of data goes there versus the cache that's very small. For instance, if we were talking about a hard drive cache, you might have a hard drive that's 4 terabytes of data, but you've only got 16 gigabytes of RAM on your machine. So clearly your cache cannot be as big as your hard drive, but that's okay. It doesn't need to be. All we want to do is store frequently used data within the cache. So some cache terminology here. We say a thing is a cache hit when the user requests some data and it is in the cache already. So we hit the cache in that case. And then that's a win. We've got our data that we want and we got it quickly. We got it straight out of the cache. No need to go to primary slow storage. The flip side is a cache miss. So when you try to get something, it's not in the cache. First thing that has to happen is the caching system has to go to primary storage, get it, populate the cache, then it can return it to the user. Cache misses will happen if you get some data that nobody's ever gotten before, or get some data that maybe hasn't been gotten in a while, depending on what caching strategy you use. The strategy we're going to talk about here is an LRU cache. LRU stands for least recently used. So how does this work? Like we mentioned, caches are limited size compared to primary storage. This means we have to decide harshly at some point what data we are going to discard from the cache. We cannot cache it all. There's simply too much in primary storage to store in our cache. So we have to have some strategy that we use to remove items from the cache, hopefully ones that we don't need in the future very often. So an LRU cache discards the least recently used item in the cache when it is full. So we keep track of the most frequently used items and we try to keep them in the cache. And if the cache becomes full, then we look at the item that has been used the least recently and we decide that probably since it's the least recently used, it is one of the least important things and we can discard that one. So how do we build one of these things? Let's build an LRU cache. We need a couple of data structure components to make this thing happen. When we have a cache, we want to be able to look something up by a certain key. So we'll have a key, that'll be like a string, for instance, and we want to look in the cache and see if the data corresponding to that key is in there. That's very similar to a data structure called a hash table, where you can take a key and pass that into the hash table, and the hash table will very quickly return a result for that key. Hash tables do key lookups in order one time. They're very fast. So this is a great thing to use for a cache. We can look up the data we need in a big hurry for any particular key. But that's not enough. We want to build an LRU cache, so we need some other kind of data structure to help us organize the data in a least recently used, most recently used way. And the data structure that works well there is a doubly linked list. And so we will have our cache entries stored in memory, and they'll be all connected in a doubly linked list, but we will also have a hash table that points to every single element in that doubly linked list. So we get kind of benefits of these two data structures here. We have a doubly linked list, the benefits it has, namely order one operations involving moving items around in it, and the hash table, the benefits it has, namely order one looking up entries by a key. So the doubly linked list, we'll need to move entries to the front of it. That's an order one operation. And we'll need to remove entries from the tail of it. That's also an order one operation on a doubly linked list. This is great. Let's see how all this comes together. So here's an example cache. It has 4 items in it. We'll call them items with keys of A, B, C, and D. And inside each of these nodes, in addition to the key of A, B, C, and D that I'm just going to use for identification during the talk, presumably there would be some additional data in there. If we were caching images, then there'd be some additional image data associated with each node in here. But here I just have A, B, C, D listed as the keys. So as we noted, the hash table gives quick access to all the entries in the cache. If we want to get a pointer to node C, we just have to go to our hash table and say, hey, look up by the key of C, please. And that'll return us a pointer instantly to C. Or we could say, look up by the key of B, and we'll get the pointer instantly to B. So the hash table gives us that quick access to the entries there. The doubly linked list is what we're going to use to order from most recently used to least recently used. In this example, the head of the list, where node A is, this is the most recently used one. And by most recently used, that means either most recently added to the cache or most recently accessed in the cache. It's been mostly recently used. Both of those cases count as used. At the other end of the list, we have the tail, the least recently used entry in the cache, and the one most likely to be discarded if our cache gets full. So let's do a couple operations and see how these work. First, let's put a new entry into the cache. Now, remember when we add an entry, that counts as most recently used. That counts as using that entry, so it has to be most recently used. Let's see how that works. So the first thing we're going to do is allocate a new entry for this table, and then we're going to move that thing over to the head of the list. So our new entry with the key of new is going to move over into the head of the list, and we also need to add a new hash table entry for that and hook up the next and previous pointers as appropriate. So this is a new entry. We've just added it to the cache, and we have done 2 things to make that happen. We've added it to the hash table by key, and then we've also added it to the head of the linked list, showing that it is the most recently used item. What if we want to get items from the cache? So we want to get an entry out of the cache this time, instead of putting one there. So this is the user saying, hey, do you have a file by this name in the cache, for example? And we can do a lookup and see if that happens. Let's say it is there. Let's say the user wants to look up item B in the cache. So they have the key B. They say, is this in here? They have a look in the hash table. Yeah, it is. The hash table hashes to that pointer to B. And so we've got it. That's great. Getting the entry counts as using the entry. So we want to mark item B as most recently used. And in order to do that, we have to move item B to the head of the list. And now item B is the most recently used. Item new used to be the most recently used, but now item B, since we just got it from the cache, is now the most recently used. Item D, still way down there at the end, has not been used. Now let's say we decided that the cache is over full at this point. We have too many items in the cache and we want to clean one of them out. The way we do that is pretty simple. All we have to do is look at the least recently used item, and we have a pointer to it right down there in the lower right. D, the tail of the doubly linked list. All we have to do is delete the tail entry from both the doubly linked list and from the hash table as well. And now the cache has been downsized, having deleted the least recently used entry. So here are some challenge questions. Go ahead and pause the video here and go out and do a bit of research and review more about least recently used caches. As always, thanks for watching.